Thanks everyone for joining. We are just waiting for more people to join in and we'll start at 11:45 with Hello everyone, welcome to the Flash Talks. This is room one of your Tech Flash Talks. My name is Tamanna Bhasin. I'm Senior Software Engineer at Intuit India and I'll be your host for this talk. I hope you all can hear me right. Okay, I think you can. Okay, so I hope you all have been having a good time at this virtual event consisting of very interesting topics. So you are going to witness some of the transformation journeys from product to platform, from monolith to microservices, and the amazing work behind some of our open source contributions. We are going to have three topics in four the rooms, which will be running parallelly. So you can jump to another webinar in the next presentation if it's in a different room. We will take questions and answers in the last leg of the talk, which is the Q&A, and you can use Q&A section in the webinar to basically post your questions. With this, I'm going to start off with our first session, and I'm going to hand it over to Poorvi Agrawal. She's the data scientist at Intuit India, and she will now be talking about survey on gradient boosting trees. All the best, Poorvi. Over to you.
Thank you, Tamanna. Hello, everyone. So today I'm going to discuss about the survey on gradient boosting trees. In this, I'll be covering what a boosting algorithm is, its implementation, and the comparison between the different algorithm of the gradient boosting on decision trees. So first of all, I would like to talk about the motivation behind choosing this particular topic. So in Kaggle, which is an online community of data scientists and ML practitioners, and it also hosts regular competitions, gradient boosting is one of the most popular and top performing submissions in a lot of competition. It can be applied for the classification problem, regression, or in the ranking space. It has many applications and libraries so that you can easily apply it in practice. Now, in machine learning, you can apply a variety of models on your data to generate the insights. One approach is that you can apply a single model on the entire data set to make the prediction. For example, the linear regression, decision tree, SVM, all these models apply a single model on your data set. Now, but in practice, when you have a complicated data set, uh, sometimes applying a single model may not work. So in those cases, what you can do is you can apply the combination. You can apply multiple models and use the combination of those to achieve your goal. So for example, bagging and boosting, these are the two types of the ensemble techniques. So when you have multiple models and you take the combination of those models, those techniques are called ensemble techniques. Random forest is the type of bagging, and XGBoost, CatBoost, AdaBoost, these are the type of boosting algorithm. Now in bagging, what happens is we have multiple good models trained parallelly, and the combination of the model reduces variance to generate the optimal prediction. Similarly, in boosting, we'll take the ensemble of weak models and train them sequentially. And then again, we take the combination of those models and generate the prediction. And as I mentioned before, we have different algorithms in each of these categories, and we'll going to look for the specifically we'll going to look at the different algorithms that is used in the boosting space. Now, the boosting algorithm. As I mentioned before, boosting algorithm tries to build a strong learner, learning from the mistake of the previous weak learners. There are three elements to the boosting algorithm that you actually must have to create the boosting algorithm. One is weak learner, second is loss function, and third is the additive model. Now, if you look at the first box here, you have five blue examples and six red dots. So let's suppose your blue examples are the negative examples, and red dots are the positive examples. Now, what AdaBoost will try to do is that it will try to fit a weak learner on your entire data. Let's suppose this is your weak learner that was fit on the data. You can see from here that there are three blue examples that have been classified incorrectly. So what it will do is the algorithm, as the next step, it will try to increase the weight of those examples that have been classified incorrectly and decrease the weights of those examples which have been classified correctly. So you can see that the weight of these three blue dots have increased and the weight of the rest of the examples have decreased. And this is the first iteration. Now in the second iteration, what it will do is it will take the updated data that you got from the first iteration and then try to fit a weak learner on that particular data. So you can see that this is the updated weights for each of the sample. And in the next iteration, which is this one, your model is trying to fit the weak learner on the updated data. Now in this example, you can see that there are four positive samples, red dots, have been identified incorrectly. So again, the algorithm will try to increase the weight of these and decreases the weight of the rest that you can see from this diagram. And similarly, this process will go on until you reach the required number of iterations that you want to do, and you'll create the weak learner for each iteration. At the end, what you will do is you'll take the combination of these three weak learners, which is here, and then generate the final model, which is the combination of these three, which is the additive model, and it is the additive model. And the pseudocode is what I have mentioned, what I've explained just now. The only thing that I want to focus here is that alpha T, which is actually the importance of a given learner. So it's related to what is the training error for each iteration. And based on the training error, it will give the importance to each of the weak learner. So this is how the adder boost works. Now going to the gradient boosting decision tree, we also call it GBDT. As I mentioned before, we require three elements to create the boosting algorithm: weak learner, loss function, and additive model. In GBDT, your weak learner is the decision tree, and that is fixed. Now, the difference between the adder boost and the GBDT is that, firstly, GBDT uses decision tree as the weak learner. Secondly, which is the most important difference, is that it does not update the weights of the sample in each iteration that we have seen in the adder boost. What it actually does is that it changes the label itself. So what I mean by that is if you can see the first tree, so this is your first learner, right? You have the feature X, and you have the feature response variable as Y, and then you're training the model, and this model is H1, and this model is giving you some prediction. Now, to train the second, to create the second learner, you take the feature as X, but you take the response variable as Y minus H1, which is nothing but the residual that you got from the first learner, right? So this is how you are creating the second model. And similarly, the third model, you will take the Y variable, which is the response variable, which is Y minus H1, and then the residual would be Y minus H1 minus H2. So this is how you are actually creating the weak learner. You're going in the iteration uh, based on the residual of the previous model. And then similar to the adder boost, you'll take the final prediction, which is the combination of all your weak learners, like weighted combination of all the weak learners. Now you must be wondering, why do we call it the gradient boosting? So the reason is that it uses gradient descent to minimize the loss function when adding a new model. What I mean by gradient descent is just a standard optimization technique algorithm for finding out the local minimum of a differentiable function. Like this is just a way that we calculate, we optimize on the weights, we get the optimal weights. Uh, Now moving on to the different algorithms of GPDT. So there are three most popular algorithms of the gradient boosting on decision trees. XGBoost, LightGBM, and CatBoost. These three are widely used in practice in the current scenario. So starting with the XGBoost, so the tree structure of XGBoost is similar to what we see in normal GBDT. It grows the tree horizontally, that is level wise, and it is known for its very high speed and high performance. The reason it has high speed is because it calculates the second order derivative of the loss function, and that actually gives the information about the direction of the gradient and how do we get the minimum of the loss function fast. uh, it also includes a regularization which enhances its performance. The light GBM, the second one is the light GBM. The tree structure is slightly different. So it grows the tree vertically, that is leaf wise. So what it does is it takes the leaf, which reduces the loss the most, and then it grows from there. So this is how the tree structure, like the way it grows the tree. Now it is very, very fast in training. It is actually 6 times faster than the XGBoost. It has, if you look at the library for the light GBM, you'll have more than 100 you'll have more than 100 parameters you can tune. And one of the parameter that you can give is categorical features. So you don't have to provide the you don't have to do the calculation on the categorical features. You can just provide the column names as what all are the categorical features in your data, and then you can just give that to the model and it will process it by itself. And it is very highly efficient for data at scale. So it is generally recommended that if you have high data, lots of data, at least 10,000 plus rows, then you should use this model. Otherwise it can easily overfit uh, like your data. The last one is the cat boost, which is short for categorical boosting. Now, categorical boosting grows the tree symmetrically. You can see that the tree structure here and here are similar. And because of this structure, its prediction time is very fast. But then it uses a lot of memory and it has very high training time. In fact, it has higher training time than Light GBM and XGBoost. It also
Purvi,
has the
just a
categorical
quick
feature. You can provide
time
the
check. Yeah.
sure, Tamanya. Yeah, so it also takes the categorical feature, and it applies the one hot encoding or advanced mean encoding at the backend. Now it is not prone to overfitting because of the way it calculates a residual of each data point. So it is it is very highly efficient algorithm. Now we are also leveraging GBDT to a lot of problem spaces at Intuit. So one of the example is that in the QuickBook Advanced product, we are identifying who are going to churn the product in the next X days, and then we can take the preemptive measure. So here we are using GBDT as the classification problem. In the classification problem, we are also using this in the to increase the adoption rate for a particular feature in the QuickBook Advanced product. Now, there are many more spaces where we are using this particular algorithm or using this to benchmark at least our models. I hope this gives you some idea about the GBDT algorithm and what algorithms to use and where. Uh, so this is it from my end. If there are any questions, I'm happy to take those.
Yeah, so Purvi, in interest of time, I don't think we'll have time for many questions, but just to take one of them.
Mhm.
So can you like help people understand what is the kind of real problem that you have been solving using the survey gradient boosting algorithm?
Yes. So as I mentioned before, so one example is the increase the adoption rate. So what we have is we'll have different customers who are using a product, and then we want to know whether they are going to adopt to a particular feature, whether they have high propensity to adopt to a particular feature in the next 30 days or 60 days or a year, right? And we are this we are actually calculating the propensity, the probability of them using a particular feature. This we are calculating based on the customer's product usage. And based on that, we can actually see that what is the probability that the customer is going to use a particular feature. And based on that, we can generate the prediction. And this is actually we are currently using in Intuit.
Thanks, Purvi. Thanks for such a great session. I think it was very insightful. For rest of the Q&A, I would encourage you guys to go to our experience zone from the homepage, and we'll be happy to answer all of your queries. With this, I'll now talk about, can you move on to next slide, Purvi? So these are the next sessions that are happening in other rooms. Feel free to hop onto those Zooms. Mahik has already pasted the link for them in the Zoom chat. Do join on other rooms. So in this room, we are going to have the talk by Ankush Tayal. He's a senior software engineer at Intuit, and he's going to talk about knowledge graph to derive business models for QuickBooks. Over to you, Ankush. All the best.
Thanks. Thanks for the wonderful talk. So now we'll talk about knowledge graph and how do we use it to derive business models for a product called QuickBooks. So QuickBooks is a product for business software solutions provided by Intuit and used across the globe. So let's take a step back. What is a knowledge graph? If you look up the dictionary, we'll find that it talks about information and truth about principle, people, places, and so on and so forth. So as mankind, we have gained so much of knowledge. And if we talk about graph, it's nothing but a data structure with edges and vertices. Edges basically represent the relations between those vertices. Now, if we try to combine these knowledge and graph, and how do we'll see how we are able to represent data and logic and convert it into concepts so that we identify a relation between any given entity. We are able to create uh, rich experience using this knowledge graph, which is based on reasoning and not just any random pattern. And this way, we as humans as well as machine, we can understand, we can combine knowledge graph to let machines as well as humans to understand the data which we want insights against. So essentially, we'll be able to explain the patterns which is we are not able to do using a classical machine learning based algorithms. Okay, so if I try to put some context, if I search a string called Bob Dylan on Google today, I'll find a couple of or a bunch of links about the person, articles and journals about the same. But on the right hand side, if you see, lately Google has introduced a panel which talks more about the search string, and that is based out of knowledge graph, and it gives direct results onto your search. So what it's able to do is it's giving you rich semantic about what you're searching for. Basically, we are transforming that search from keyword based search to a things based search. Basically, we are able to put references for that search. And essentially, if we drill down, what Google just said is, hey, I understand what you're looking for. You're looking for a famous person called Bob Dylan. And I have defined entities within. So beneath the results, what we see on the right hand side, like the personal information about the person and what musical albums he's composed and so on. Uh, it's working because of the knowledge graph beneath, which has billion of entities and huge amount of relations which define those entities, those real world people, places, etc. So what we are seeing on the right hand side is representation of a knowledge graph for an entity called Bob Dylan, wherein this entity will have multiple attributes. For example, what is the gender of this person, where he was born, where he lives, and so on. So there are directed edges going outside this entity uh, to various of its attributes, and there will be incoming directed edges as well. For example, Steve Jobs is a fan of Bob. So these relationships like has gender, born on date, and fan of, these are all defining the entities. So this is truly helping to this knowledge graph is helping the way to how to make sense of the query and to put explanation about the patterns which are being introduced using knowledge graph. Another quick example of knowledge graph is Wiki Data. It's basically an open source knowledge graph based out of Wikipedia textual data, which we have gathered over years and years of humans adding data onto Wikipedia. So it's a great structured data set wherein you and me can go and edit the schema. For example, if you look at a particular entity called Douglas Adams, we can define a schema having a label, description, property about the person, and we can add attributes against that. Okay. So essentially what we are able to do is using knowledge graph, we can add meaning to the textual data and information which was sitting in Wikipedia, and we had to go to the data. Now we can bring that live in a shape of knowledge graph. Okay. So that was about what is happening in the industry using knowledge graph. Let's take a quick look at a use case within Intuit, which we tried solving using a knowledge graph. So before that, let me quickly talk about a product called QuickBooks, which is a business solutions software. And we have millions of customers across the globe, which small and medium business owners who use this product on daily basis. Recently, we shifted our business model from a outright model to a subscription based model, wherein we want to find potential customers who would like to or who would benefit from a subscription based model. We call that as a plus customer. So basically, essentially what we are looking for is a recommendation engine which can give us our potential plus customers. So that's a use case we are trying to solve using knowledge graph. And how do we do that? In three simple steps. So Part one is we simply create that, convert that data of relational relations into a key value pair. For example, a company can have n number of employees. That becomes a line in our data set wherein a company C1 can have attribute like number of employees, right? And I'll be talking about these diagrams in a while when I go through the demo. So once we have converted and injected that data into a knowledge graph based database, uh, we can define similarity between any two given entities. Let's take an example. If we have two human beings and we want to find similarity between those two, we'll look at all the similar attributes of those two people, and then we'll try to see what all similar attributes are there, and overall what all attributes define those two people. So we essentially, what we're looking at is the common attributes between those two, any two given entities, and that's why we can apply a Jaccard based similarity algorithm. What it simply means is we are looking at the intersection of the common attributes between any two entities, and we'll divide that by all a union of all the attributes which define those two. So once we have similarity between any two given entities, we can scale out. We can say that for a given plus customer or for any given particular company, we can find similar such companies and get top n number of companies which are similar to the given one, right? So essentially we are able to solve our recommendation engine problem using something called knowledge graph. So let's take a quick demo and understand it better. So here we are using a database called Tiger Graph, which is based on knowledge graph concepts. So first, so what we are looking at right now is a graph studio, which is again given by Tiger Graph as a UI, and it has, so it makes our life simple by using SQL-like queries. We call it GSQL, graph-based SQL. And what we did is we, after converting our data into key value pairs for a particular company, we injected all that data into Tiger Graph. And currently, what we're looking at is, if you could recollect the Bob Dylan example, where where we are defining the entity called Bob Dylan. Here we are trying to define an entity called company, and company ID maybe says C1. Essentially, what we are looking at is this company is having some kind of product. It's uses some product. It's part of an industry, a particular, say, a transportation industry or something, and then it has a company size. For example, how many employees, vendors, users, and so on. So we are trying to define attributes for for that particular company, and then we also know that this is a plus customer or not. So that becomes our Y attribute, as in that becomes our target attribute to know upon. A few more things about the company like we can look at to put this knowledge into the graph. We can look at what was the P&L for this current financial year, for last financial year, what was the total expense, total sales, and so on. Essentially, we understand what the company looks like. And if I may give a little more background about this Tiger Graph, we simply defined a schema having two entities and couple of edges. These two entities, company and attribute, uh, is being defined by an attribute called has attribute. And then we are also putting some weight because we want to see how far or how similar are these two companies. Also, each attribute can define that company on a scale. For example, if it's a big company and has large number of employees, we'll put more weightage on that edge which goes from company to employee, right? So we're defining a weight on each edge as well. Okay, so once we load the data and look at how, let's see if we are able to find similarity, and recollecting the Jaccard-based similarity algorithm, wherein we are looking at intersection. We are basically looking at intersection between a given source company and all other companies. So if I may say, once we define similarity between any two companies using this equation of intersection, and we divide that by all the attributes common to those two attributes companies, we can put a for loop and find similarity for this particular company against all other companies in the ecosystem. So for example, if we have a million companies, we can say we can find all other similar plus companies, right? So that's what we are trying to do here using Jaccard based algorithm. So once we apply this, let's see it in application. Okay. Um, so I'm loading a random sample of a company called C981. That's just an identification for a company. What it depicting is first of all, we are able to visually represent this company in a graphical format, and it's easy to understand. We can explain what this company looks like today. What is the business? What type of business it's into today? For example, what is the user count? How many payments received? Is it a plus enabled or not as of yet? Is it using payroll, payments, etc.? How many invoices created, and so on and so forth. And each of these edges is also having some weight defined so that we know how, what is the scale of this company basically. So let's apply that Jaccard similarity algorithm, which we did on a company. We are giving this as an input to that algorithm, and we want to find top 10 similar companies. And once we then run the query, and what it spits out is all other 10 similar companies to the given company, and we are seeing a similarity score of 80 to 85%, which is pretty good, right? We're able to now find similar companies to the one uh, uh, to the given source company. So essentially, what we have done is we've applied Tiger Graph as a uh, knowledge graph based database, and then we are finding similarity between a given company to all its neighbors, and we can finally recommend which all similar companies are are there in our product, which we can recommend uh, to start leveraging subscription based model. And we chose Tiger Graph for this because it's quite a scalable solution, and we can leverage it to have 6 degrees of separation in terms of loading the data and getting mining that data on using graph-based algorithms. And it's useful for clustering. We can use it for page rank algorithms and so on and so forth. It's actually I may call it as native parallel graph, because we are able to define um, uh, we are able to use it for many such purposes, and it scales out really well. So yeah, and there are many inbuilt features, like it's giving a UI where we can visualize the data, and we can also use GSQL like queries. We can define our own queries to define the algorithms using the concepts of graph mining, right?
Ankush, just a quick
So
time check.
sure, yeah. So quickly, I'll talk about what learnings we had in this journey. Definitely, we are able to visualize the company persona, and not just for this use case. That was just one use case for recommendation engine. We can use it for many other purposes, for many using graph-based mining algorithms. And one thing which we noticed was that data cleanup it takes up a lot of data time for and resources for us, and that's no surprise, right? And we'll keep exploring knowledge graph using Tiger Graph based approaches, and we'll also look at other solutions in the market, for example, Amazon Neptune and the Neo4j, for example, and we'll find some comparison between both of those. And finally, we like to connect our current QuickBooks product usage to a customer 360 graph finally, so that we are able to leverage this and connect to all other QuickBooks products, and not just in QuickBooks, but also other products like TurboTax, etc. I'll now take rest and open up for questions.
Yeah, so Ankush, we have a couple of questions from our audience. So one question is like, is there a threshold to identify the most similar companies?
Yeah, so that's a great question, and that's part of validation process wherein we are able to give apply some threshold. So far we have kept it as 80%, but we are trying to see how we can further enhance it. But yes, we can. Uh, so as part of the algorithm which we have defined, we are not defining a threshold. We are simply taking top n number of similar companies, but we can definitely create a threshold and put it in the query. If I may show you the query here. We After we get top k similar companies, we can filter out only the ones which are um, getting above the threshold of the similarity index, which is nothing but the Jaccard similarity index. So yeah, we can define index and use those similar companies as a result. Hope that answers the question.
I think we have quite a lot of questions coming in, but we'll take most of them on our booth. So just one, I think it would be a pretty fast one. Is
Sure.
this same as association rule algorithm?
Yeah. So in association, we are looking at how is an entity associated to another entity, and it is very similar to that, because using knowledge graph you're able to define relations between the entity, and what is not visible explicitly, if you're not using something like a knowledge graph. uh, unlike other solutions in knowledge graph, you can define associations or relationships between the entities, which wherein think of it like a knowledge being injected into data, and the database itself is giving you relationships or associations between the given entities. So yes, it's we are able to apply algorithms on basis of the relations which are defined onto the graph, within the graph. Yeah.
Okay, so in the interest of time, I think we'll take rest of the questions offline. So you can actually visit to our experience zones from the homepage, and we'll be happy to answer any of your queries. Thank you so much, Ankush, for such an engaging and insightful session. I think everybody enjoyed it. While parallelly we talk about the next session that we're going to have, these are the sessions which are parallelly happening in room 2, room 3, and room 4, and the Zoom links for that are being shared in the Zoom chat. With this, now we'll move on to our third session, which is from Priyanka Bansal. She is a software engineer too at Intuit India, and she's going to talk about OIHS integration with ProConnect, which is one Intuit help system. Moving on to Priyanka, all the very best.
Thanks, Tamanna and Ankush. It was a very, very motivating talk. And as we all know, the culture we have at Intuit, I am going to definitely talk to him offline and see how I can basically leverage this while within my the products that I am working with. So hi everyone. My topic today is integration of One Intuit Health System with PCG offerings. Now I know there might be some terms that I might be using which might be Intuit specific, and I would try to mention as much as possible. So so I am part of PCG team where we have three tax offerings which cater to different kinds of customer sets, and basically they are built on different tech stacks, and we have different kinds of features that are available with each product. Now I will like to start with what is the problem statement. So we started with the first initial problem statement was we wanted to give our customers a help system within the product, like where they can ask questions and they can search for Intuit generated content, knowledge based articles within the product, not basically having to leave the product and search in the web. So that was the first initiative, and then we realized that every product today, so the products that I was talking about are Lessert, Pro Series, and PTO. So every product had different solutions within themselves. Every product had to build their own help platform. Every product had to configure their own knowledge based articles and community help, and that was a very cumbersome and heavy on maintenance. So as we were developing and Intuit has a lot of basically platform level solutions, right? And one Intuit health system was one of them. I would like to talk a little bit about this diagram, which will help us to basically understand what is the whole ecosystem, right? So these are the products that we have. These are the this is the online offering, which is PTO. So this is web-based solution that we have, and we have Lessert and Pro Series, which are desktop offerings. Now we wanted to create a health system that is very generic and common to all the products. So how did we go about it? Now in this diagram, right, there is one Intuit health system, which is a platform-based solution for creating generic health system, which can be used by different products within Intuit. And now, how is this built? So this is built using the plugins that are generic and foundational capabilities that are shared across Intuit's ecosystem. They are built with common CI/CD pipelines. They are built with common reusable and extensible UI frameworks, which can be extended over any product. And that capability is enabled using App Fabric within Intuit. What is App Fabric? It is a platform contained of foundational capabilities that are shared across Intuit ecosystem, and this enables us we work at different levels at different teams catering to different products, right? It helps us it helps us as a team to basically uh, create composable widgets and follow a Intuit specific standard designing system. And how that basically is beneficial to us is we can create it once. We can use this ecosystem to create solutions specific to our products and extend it with multiple products. Now, how we solved the desktop. So adding this web-based framework within desktop was not an easy job. It was, there were challenges, and what basically we designed a very sophisticated solution, which where we created a generic help library that basically created an interface between the web and the desktop. Now, this library again is very generic, and it is not only limited to the help system. Now, using this library, we can integrate any web page, any widget created within Intuit to basically show that widget within the product. And I, I can not tell you how big an advantage this is, because going forward, we can design solutions within our products that are web web based and that do not need a release within desktop um, to basically roll out this use cases to customers. For example, today, if we have to make any change within the desktop offerings, we have to do a release where our customers are um, they have to basically upgrade to the latest version of the product. And using this framework, if we develop anything, if we design a feature that we want to cater to our customers, we need not do a release. This releases are online and customers will get the features real time. So I will go to the demo part where I want to show you both the products. Like, this is our online product, and I will show you how the help looks within the product. So this is our health system, and I am going to search for the same term within this product and within desktop product, and you will be able to see how using the same solution, we are able to configure product specific search items, and there are articles and community specific answers, like answers that are answered by our co-users, and articles are something that is answered by the KB articles published by Intuit. So if you see how to connect contact Rotax for help, this is very specific to PTO. Now, this is the kind of level of configuration that we can do, and we have used the same solution across these two products. So how this is beneficial to us is basically this helps us to maintain the similar look and feel across the products, and also create ones and use multiple times. Now, there are many benefits to using this kind of framework, and at Intuit, we really believe in creating ones and using multiple times. So while we were developing this solutions, right, we actually shifted. We had a mind shift to things that when we are creating solutions, we should create in a way that others can use it. And there are multiple examples after we onboarded to One Intuit Health System. Whatever solutions we are creating, we kind of tend to fall into that mindset that yes, if we are creating something, we should be able to cater to all the products within Intuit. And I think that is a um, very drastic mind shift, and Intuit basically enables in that. While we were developing One Intuit Health, while we were integrating with One Intuit Health System, we were also able to contribute to the um, central repo, and it was very easy. It was open contribution, and the things that we contributed, when other teams are using those features, they realize that yeah, it makes sense for other products as well, not just within my business unit, but other business units and other products as well, and they can extend that eventually going forward. So this basically has enabled a lot of learning within teams, the teams that are using the solutions and the teams that are basically contributing to enabling this kind of technical solutions. So I think I am good with the presentation. I am open to take and happy to take questions.
Thanks, Priyanka. I think this was again a very good session. So we do have like a couple of question mark Q&A, and I do encourage you rest of the folks, you can post your questions in Q&A section. So how did you make sure the platform that you are making is generic enough to encourage adoption, that you mentioned about being used in other teams as well?
So yeah, so one of the examples I can give in this context is, so help system is generic. There you ask questions and you get results. And when it was created in the central framework way, so before we shifted to the central health system, right? We had our own health system, and there were a couple of features that were not present in the central health system, like login context. Like if you're in the product and you're already logged in the product, you need not log in again to the community page, because suppose you want to ask a question, it has to be yours. User specificity should go with the question, right? Or suppose you want to upvote a question, or you want to downvote a question. So this kind of features were not readily available, like login context, passing the login context to the help system. So basically we had already had this solution, and we suggested this solution. And when we integrated this solution with our solution, basically there were other teams that realized that this is going to be very helpful for them as well. And so this we made a generic, we basically contributed back to the central repo. And now this basically solution is available for other products as well. And there are multiple other examples, like mm, so in the product, like I want to show you this specifically. So this, right, so there is a search box where you can basically type, you need not go to search and then type. Basically you can directly type your search term here, and then launch the help. And basically this feature was again not available within the central help repo. And when we enabled, so this became a generic feature now. So these are the kinds of example that we talk to other teams, we talk with each other, and share the solutions that we have, which makes sense for everybody.
Okay. Other question I got is like, you guys have any plans to make it open source? Like I heard in the talk you were mentioning about it being very much specific to ProConnect, but just for the sake of audience.
Yeah, I mean, it could definitely be made open source. The App Fabric is a very, I mean, extensive solution for catering to all kinds of widgets created in JavaScript and React. And it can basically, it has all the pipelines already defined that is needed within Intuit to release, to create the plugin. I mean, as a desktop developer, I mean, that was my shift. Like as a desktop developer, I was not in the beginning. I was worried, like, how am I? Do I have to take course? Do I have to understand the new concepts? But the whole pipeline was so easily set that I could easily onboard to the new ecosystem, new tech stack, and understand the features, like what all I can use, what all widgets I can create. Again, widgets are small React components, independent React components, which has independent features. And I think it is much capable of being open sourced. Very much capable of being open sourced. And yes, that is definitely in the lines.
Thanks, Priyanka. And so I think again, in interest of time, we'll have to cater to other questions on our booths. So now
Sure, I'll
everyone
be
will
happy to.
actually break for lunch. Yeah. So from 12:30 to 1:30, we are going to have a lunch break. Thank you very much. Hello. Yeah. Thank you very much, Priyanka, for this session. So basically in lunch break, you can actually visit our booths from the Experience Center, and you can actually talk to our talent acquisition team, Intuit Circles team, CSR and Innovation Catalyst team for the interactive zone. Don't forget the last leg of our treasure hunt is going to start now. So, and after post lunch, basically, we are going to have a mindful session by Shinomics. Don't miss it. I think it's going to be really impressive session apart from the tech talks that we have been doing. Hope you guys are having fun. Enjoy rest of your day. Thanks. Thanks everyone.